Good morning, grade threes. Welcome to our thrilling Math Thursday today. And today we have quite an exciting and thrilling math lesson to do. We are doing math lesson number 7 in our Module 7 Learn books. So we're going to get started in just a second. I'm going to be sharing my screen with you so that you can all see what I'm doing. I'm going to move my handsome face over here into the corner. There we go. All right, so today's learning objective says, I can reason about composing and decomposing tetrominoes. Now that's kind of a weird thing to think about. Firstly, let's think about what composing means. Composing is when we put two things together. So when we build something that is made up of two or more parts, and we put them together to create a whole. Decomposing is when we take that whole and we break it apart into its two or more smaller pieces. So today we're going to be moving some things around, and we've been learning about shapes, especially polygons and quadrilaterals. So we're going to be putting them together and taking them apart and seeing what we make. And there's one more word here. What word is that, Brain? Tetrominoes. Well done, Brain. What do you think a tetromino means? I don't know. It sounds like two words made up together. You're right. One of those words would be dominoes. Well done. So something like dominoes. And what about the tetro part? What do you think that means? Tetra. Whenever I hear tetra, I think of the game Tetris. You're right, that game where you have the building blocks and they fall from the sky and you have to put them together to make a tower. So we know that our dominoes are called tetrominoes because they are all Tetris block shaped pieces. So we're going to have quite a lot of fun today moving these around and building quadrilaterals and polygons with them. Hooray! Yep, I'm excited. All right, today for our lesson, we will need our math journal, of course, our learn book open to page 31 and 32, our practice book open to page 109, and our succeed book with our homework for page 195, 196, 197, and 198. So if you don't have all those ready yet, pause the video here, go ahead, get what you need, and push play when you're ready to start. All right, let's move on. Today we are going to be starting off doing page 109 in your practice books. So you can pause the video here and get started right away solving every single sum. It doesn't matter how long it takes you. Try to do every single one on page 109 of your practice book. And when that's done, you can push play again and get back to our video ready to check it. Welcome back, grade threes. All right, here is our page that we did from our book, page 109. So Brain and I are going to show you what you need to be doing when you check it. We should be reading out the sum and the answers. So 5 times 1 is 5. 5 times 2 is 10. 5 times 3 is 15. 5 times 4 is 20. All right, so grade threes, you can pause the video here, make sure you're looking on this page, and go ahead, read all the multiplication equations out with their answers as you check your work. After you finish that, just push play and we'll be moving on to our next page. Welcome back, grade threes, well done. All right, we are going to be doing some fluency practice first. And in order to do this, we are going to need to stand up. So I'm going to be modeling what you need to do to stand up. I'd like you to just stand behind your chair and you can do this as you watch the video. So here we go. I'm standing up and I'm gonna stretch my left arm up towards the ceiling and my right arm parallel to the floor. What type of an angle do you think I'm making with my arms? It's kind of tricky. Sometimes we draw a box in this angle to show that that's the kind of angle, right where my head would be. It's called a right angle. And now we're gonna switch our arms and we're gonna put our right arm up and our left arm out parallel to the floor. And now what kind of an angle am I modeling? Right where my head would be, I could draw a box for it. It's called a right angle. So well done, grade 3s. You can have a seat, ready to move on to our next slide. Remember, a right angle always looks like the side or the corner of a square. All right, let's move on to our next video. Here it is. We're going to be doing some fluency practice. You can stand up for this and you can try to do these activities by yourselves. I know for this, we were meant to be doing it in school, so we were supposed to have a partner. But instead of using a partner, you could try to use a wall, or you can just do it with your fingers. So how many sides does a triangle have? Brain, 3. And go ahead and make a triangle with your arms on the wall. I know it might be a little tricky. One way to do it is if you're standing sideways, put one arm out straight and the other arm going up like that, and put the wall in between, and you'll make a triangle. You might need to stand like that to have both your fingertips touching the wall. We just made a triangle. What do we call a four-sided figure? A quadrilateral. Well done. We call it a quadrilateral, and it has 4 sides. So it might be tricky. I'm not actually sure how you would do this, but see if you can make a quadrilateral with your body and the wall. One way is that you could use your arms going out. And if you're sitting flat, you can stick out your legs nice and straight there. Here we go. And your body straight and your arms straight, and the wall with your fingertips and toes would be touching the wall to make 1, 2, 3, and the wall would be side number 4. You'd kind of look like a rectangle. All right, for our next video, we are going to be looking at this shape. So pretend that this shape is a room and each side is a wall. Which wall is opposite the wall with a star? So here's our star. Which wall here is opposite that wall? Well, that's easy. It's this wall right over there. Remember, opposites are always directly across each other. And that means that that same wall is parallel to the wall with a star. Now, we need to figure out which wall makes a right triangle or a right angle with the wall with a star. So which wall makes a right angle to the wall on the star? And there are 2 of them here. So let's see if we can figure out which ones they are. Let's see, I'm gonna use my square because I know a right angle looks like the corner of a square over here. And I'm gonna put my square in a corner to see if it makes a right angle. Let's see. That looks just like it makes a right angle. So that means that this wall over on the left over here it makes a right angle with the wall with a star. And I'm gonna use another shape that also has a right angle. I'm gonna use my triangle because this little corner down here makes a right angle. So let's see if it fits in over here. There we are. So we know that this wall over on the right-hand side also makes a right angle to the wall with a star. All right, let's move on to our next slide. For this one, we're gonna do a bit more of a shout out. So I'm gonna be asking you a question. I'm gonna give you a minute to think about it. Try to say the word out loud, and then we're going to check it and we're gonna see if we are right or not. I'm gonna have Mr. Brain here help me with our answers. So How many sides does this polygon have? How many sides does this polygon have? Here's our polygon. How many sides does it have? 4! Well done. What do we call a polygon with 4 sides? It has a special name. What do we call it? A quadrilateral. Good work, brain. How many sets of parallel lines does this quadrilateral have? That one's a little tricky. Let's see if we can find our answer, brain. 1 set! You're right, it's got 1 set. This line and this line are parallel to each other. This line and this line are not, because this one goes down at an angle and this one goes up at another angle. So they will eventually meet. We don't want that when we think about our parallel lines. Parallel lines never meet and never touch. All right, what do we call quadrilaterals that have at least 1 set of parallel lines? Think back, use your brain, and see if you can remember. What do you think it is? Let's see, brain, what is it? Trapezoids! Well done. A trapezoid, because it looks like a trapeze that trapeze artists would swing on in the circus. All right, let's move on to our next fluency page. We're going to be doing the same thing. Let's look at this polygon over here. Is this polygon a quadrilateral? And make sure you say with your voice why it is a quadrilateral. Is it a quadrilateral and why? I'll let you have some thinking time. Say your answer out loud. Yes, it is a quadrilateral because it has 4 sides. How many right angles does this quadrilateral have? Let's look at it carefully. How many does it have, brain? None! None of those angles make the corner of a square. You're right, because these 2 lines here are at an angle going down and up, so that it cannot have right angles. Is this quadrilateral a trapezoid? And why is it a trapezoid? Think about that. Make sure you say your answer out loud. Is it a trapezoid? And why is this quadrilateral a trapezoid? Yes, it has at least 1 set of parallel lines. This line and this line are parallel. They will never touch. And this line and this line also are parallel with each other. These 2 lines will never touch either. So there are 2 sets of parallel lines in this polygon. And brain, how many sets of parallel sides does it have? It has, whoopsie. It has 2. I'm not sure why that's not moving. All right, brain, our last question for this slide says, what do we call a quadrilateral that has 2 sets of parallel sides? Remember, it's got a special name. What's that name for it? We call them a what? A parallelogram! You're right, and the word parallel is even in the word parallelogram. So we know that we can use that to remember that a parallelogram always has 2 sets of parallel sides. Let's go to our next page. Is this polygon a quadrilateral? And why is it a quadrilateral? Make sure you're saying your answer out loud with your voice and saying why it is a quadrilateral. I'll give you a minute to do that. Brain, what do you think? Yes, it has 4 sides. Well done. How many right angles does this quadrilateral have? I'll give you all a minute to look. Remember to say your answer out loud. Brain, how many right angles are there? 4 right angles. Good work. Is this quadrilateral a trapezoid, brain? And remember to say why. Grade 3s at home, make sure you're saying out loud whether it's a trapezoid or not, and saying why. I'll give everybody a minute just to do that. All right, brain, what do you think? Yes, it has at least one set of parallel sides. You're right. In fact, this one has two sets. These two lines are parallel and these two lines are parallel. So is this trapezoid also a parallelogram? And why? Make sure you're saying it out loud. Is this trapezoid also a parallelogram, and why? Yes, it has two sets of parallel sides. You're right, and a parallelogram always has two sets of parallel sides. Is this parallelogram also a rectangle? And why? I'm going to give you a minute to think and to say out your answer out loud. Is this parallelogram also a rectangle, and why? Well, brain, what do you think? Yes, two sets of parallel sides and four right angles make a triangle. You're right, and it's got two sets of parallel sides and four right angles, so it is a rectangle. Brain, one more question for this slide. What do we call a quadrilateral that has two sets of parallel sides? Mr. Dim, I think you've asked this question before. I might have, brain. Let's see how many of our superstar scholars at home can remember the answer. What do we call quadrilaterals that have two sets of parallel sides? Parallelograms! Good work. Well done, grade 3s. Well done, brain. All right, let's get ready for our next one. Let's look at this polygon over here, and we're going to classify it. Is this polygon a quadrilateral, and why? Make sure you're saying your answer out loud at home, and you're saying why you think that. I'll give everyone a second to say it out loud. Yes, it is a quadrilateral. It has four sides. How many right angles does this quadrilateral have? Go ahead, have a look, see if you can find any right angles there. I see brain is looking really hard. Brain, how many right angles does this quadrilateral have? None, there are no right angles. You're right, these angles at the top and the bottom are too big to be right angles, and these ones on the side are too small to be right angles. So brain, my next question, is this quadrilateral a trapezoid, and why? Grade 3s, make sure you're saying your answer out loud at home and saying why. I'll give everybody a second to do that. Yes, it has at least one set of parallel sides. Well done, brain. Is this trapezoid also a parallelogram? And why? I'll give everyone at home a chance to say out their answer out loud, and they're thinking of why. I see brain is thinking really hard. I know everyone at home is thinking really hard too. Yes, it's got two sets of parallel sides. Well done, brain, and well done to all the grade 3 superstars who are getting these answers. Is this parallelogram also a rectangle, and why? I'm going to let everybody have a think. Remember what a rectangle has. Make sure you're saying your answer out loud. No, it has no right angles, and a rectangle always has four right angles. Well done, brain. All right, our next question. What do we call a parallelogram with four equal length sides? Four equal length sides. It has a special name. A rhombus. So this shape is a rhombus because it has 4 equal length sides and it is a parallelogram. What is a rhombus with 4 right angles called? It's got a special name. What is a rhombus with 4 right angles called? You can remember that name. Brain, what do you think? A square! You're right. And how else can we classify a square? We know a square is a rhombus with 4 right angles. How else could we classify a square? Well, we can classify a square as a trapezoid, a quadrilateral, a rectangle, and a parallelogram. A square has all of those traits in common with it, these other types of shape. Good for the square. All right, let's move on to our concept development. All right, I'm gonna put Brain down for a second because I'm gonna be really busy moving things around on the screen for you. Remember, our concept, our learning objective today was to be able to compose and decompose quadrilaterals using tetrominoes. Each of these shapes here is called a tetromino. You may have seen them if you play the game Tetris. I love Tetris. I used to spend hours and hours and hours and hours and hours doing nothing but playing Tetris on my Game Boy, and then I became a teacher. So now I don't have time for Tetris. But Tetris, the game, uses these blocks. Let's have a look at each one. Each of these is measured in a measurement called square units. Something that can help us remember that is each of these blocks is made up of squares. This shape is made up of blue squares. This shape is made up of green squares. This shape is made up of yellow squares. This shape is made up of red squares. And this shape is made up of purple squares. What is the area of each block in square units? One way that we can go ahead and figure that out is just to count. How many squares are in each of our blocks? Let's find out. 4 square units. So each block is 4 square units because each block has 4 squares in it. To make shapes, sometimes we need to flip or rotate some of these shapes around so that they can fit together. Again, if you have been playing Tetris before, you'll know what it means when you turn a shape so that it can fall into the right place. Before we get started with the next step, I'm going to ask you to open up your Learn books and go to problem 1 in your problem set.